So before we actually start talking about the Mutex group, I think it'll be prudent to talk about exactly what a group is. Groups in GL Studio are more than just a means with which to organize the objects within our scene. In addition to being a way to organize, we can also use these to provide array index, or pretty much array access into a group itself. And we're going to be using this today to really ease the display page changing logic between the buttons in our MFD down here in the bottom with the page in the top. The first thing we're going to go ahead and do is actually create a regular group with our GL Studio push button objects. So I'll select these, and inside our convert menu simply just say create group or group selected objects. So now we have our group named button 0 group. I'm just going to go ahead and quickly rename this. BTN group will be just fine. So what I've done here is created a group, and inside the group we have our 6 push buttons. You notice I named these button 0 through button 5. The reason I named them this way is because inside our array, or inside our group, we have an array of 6 objects. Array sub 0 will be the topmost object, which is button 0, and then our last object, array sub 5, will actually be our button 5 push button. And as I mentioned, we're going to be using this a little bit later on. So now that I've talked about what a group is, let's go ahead and go right into the Mutex group. I'm going to go ahead and select our screen 0 through screen 5, which you'll see they're currently invisible, but the backgrounds, when I make these visible, we can see that these correspond to the different colors on the bottom row. And we're going to be using this to actually demonstrate how our display logic works. So we've highlighted all 6 of these objects. We're going to go ahead and now create a Mutex group, which is this button located in the lower right of the Convert section of our tool tray. And now we've created a single Mutex group. Quickly, I'm going to go ahead and just rename this, and we'll call it Screen. So now we'll notice that our fuchsia or pink background is visible. And the reason this is because that's what our topmost array object was up here. Looking at the project properties for our Mutex group, we'll see exactly why we're seeing the topmost object and not the bottommost in our draw order like you would normally. The thing that makes a Mutex group or mutually exclusive group different from a typical group is that only one object inside the Mutex group is visible at a time. This is determined by the object's Mutex state, as we can see in our object properties. Mutex state is essentially the array index inside the Mutex group of which object is displayed. In this case, we have Mutex state 0, which corresponds to our array sub 0 inside our group, or in this case it would be screen 0. If I change this to, say, screen 1, we can see that the display now changes to the color green, which corresponds to our button 1, or array index 1 inside our button group and our screen. Another feature of this, if we want to set this to -1 for the Mutex state, we'll see that our screen goes entirely blank. Mutex state of -1 means that there is no object that is no object in that group is being displayed. So I'm going to go ahead and quickly cover the different properties of our objects in our Mutex group. We've already seen what the Mutex state does. I'm going to go ahead and sort by class so we can actually see the things that are relevant completely to the Mutex group. We have checkboxes for calculate and pick invisible states, as well as pre-drawn visible states. These can be selected and deselected in order to improve the performance of your application. You may have let's say instead of having just regular polygons here, all these are different display pages. What we can do is uncheck calculate, pre-draw, and pick on, uncheck the calculate, pick, and pre-draw invisible states options for this particular Mutex group, and what that will do is it will ignore calls to calculate, pre-draw, and pick inside the objects that aren't currently visible inside the Mutex group. So if we have a bunch of very complicated pages that are all different components, only the one that's actually being rendered is actually being manipulated and is having its routines being updated and pre-drawn. This can save a lot of performance if you have a very large application which consists of multiple buttons or multiple pages. Input device behavior. I'm going to go ahead and cover this towards the end of our webinar today. And yeah, we'll just leave it at that for now. So let's go back to our application quickly. we have a single MFD, which has a row of 6 buttons. And what we're going to want to do is we'll want to use our Mutex group to provide some kind of a page-changing behavior. We'll say if we want to click on button 0, we want to see our 0 background or our 0 screen in the display, our fuchsia screen. They will all correspond to, of course, the different button colors will be the different color backgrounds. So to do this, what we'll do is we're going to go ahead and switch to our code view. And we can see exactly how our Mutex group can be manipulated in code. So of course, the first thing we need is if we have a button, we're going to need to create a callback for that button. So we'll go ahead and go into our object callbacks. We have our button 0 selected, so we'll go ahead and click and edit to create a new callback. Of course, we know object callbacks return an integer, and they take in two arguments. They'll take in this case, a push button pointer known as self, and a display event pointer, EV. The push button pointer is, of course, going to be the exact push button, or the memory address of the push button that we're returning for the callback. And the display event pointer is going to be pretty much a message that says exactly what is being done. So if we go in here, we'll go ahead and use insert predefined code to create a shortcut and say that our push button position has changed. This brings in our if object event is, which is a function that checks our event, our display event, to see if the state has changed, or if we have a state change message. We're going to take this a little bit further and say specifically if our object event is a state change and our self pointer's state, in this case our button state, which is 0 for up and 1 for down, is down or equal to 1. Let's go ahead and make this a little bit bigger. If that's the case, we're going to want to go ahead and change this page. Well, in order to do that, as I mentioned before, the Mutex group, or any group, is literally an array. And we can access a specific object in the array. So what we're going to want to do is say, okay, well, screen, we want to change, and we see our IntelliSense come up. We want to change its Mutex state. We want to change it to whatever our array index is here. In this case, button 0 is at array sub 0. So it would say, screen's Mutex state, you're now equal to 0. And this will change the screen to be, or our active Mutex state to be screen 0, or our pink screen. So we'll go ahead and complete this by saying, okay, well, we've handled this event, so handled is 1, and then we return handled. Now we could go through and do this for every single one of our buttons, but if you've noticed, this essentially would be the exact same behavior for all 6 of our buttons, and the only thing that's really changing is the Mutex state. There's an easier way to do this. We'll go ahead and do so by creating another class method. This class method is a button callback. The button callback method, which we create by right-clicking and going add method, is right here. We'll call this button callback. We'll have it return an integer, name it button CB, and give it 2 arguments. We'll have a GLS push button pointer for self and a display event pointer EV. Now this should look very familiar to the, or very similar to the object callback we just created a second ago. So what I'm going to do is I'm actually going to take this entire object callback, I'm going to copy it and paste it into this method. So what we have here is a single button callback. We're going to handle it the exact same way as our regular object callback is. We're saying if our object event is a state change and the button is down, the self state is down, we're going to go ahead and change the Mutex state to reflect whatever button it was that was being pressed. Now, of course, since we're here in state 0, we're going to want to go ahead and change this. We're going to want to make this generic to any button. Well, as I mentioned, a group is an array. We've seen how this works with the Mutex group by using the Mutex state function. However, the button group can do this as well. So we'll call button group, and we'll say, hey, button group, I want to know what position, let's try that again. I want to know what position the self pointer is located in. The position function will take in a object pointer of some kind, In this case, it's our push button pointer self, and it returns an integer corresponding to what array index that particular object's located in. So in this case, if we're using button 0, calling button group's position and passing in button 0 for self is going to return 0 because it's located at array index 0. Then, of course, we could pass this into the mutex state, which also takes in 0, and will correctly change us to the correct screen. So this is pretty much a 1 or 2 line function that will handle all of our button callbacks. So now that we've created this, let's go back to our original button 0 object callback. We'll remove everything inside the button's callback and simply just tell it to return button CB, passing in self and EV. So this is our button 0 object callback. Our other objects, our other buttons are going to be handled the same way. So we'll go ahead and group select all of them, click on selected object callbacks, and click in Edit to create a new callback. Once again, clearing everything out. And just like with button callback 0, we're going to go ahead and return the return value of button CB, passing in the button pointer and the display event. Clicking out of here, we can see that this automatically fills in all 6 of our buttons with this exact same code. So now that we've done this really quick and easily, we can go ahead and compile our code. And once our code is compiled, we're going to go back into our IDE and actually test this out and see how it works. So as we can see, our files have been generated. We'll go back to Visual Studio. I'm using Visual Studio 2008. And we're simply just going to go ahead and build. I'm going to go ahead and make sure our code's properly built, generated. Okay, there are no compiler errors. And we have now on our screen our Mutex group application. So based on the logic that we had from our groups, our array indexes, if we were to click on button 0 calls the callback calls our generic button callback, and it pretty much says the object at our button group's index, in this case it's 0, we're going to go ahead and change the mutex state of our mutex group to match that, which once again is 0. This will work the same way for button 1, button 2, button 3, button 4, and button 5. So as you can see, this is how we can use a mutex group to create very simple page changing logic. I'm going to go ahead and talk about the last feature of the mutex group, which is input device behavior. I'm noticing one question, is GlsMutex group compatible with the safety critical? The answer to that question is actually no, it's not. The GlsMutex group is available only in our standard runtimes. And quickly, let's go ahead and I'm going to open up one more document. Before we began our webinar, I created one more very simple object. And switch this back to our geometry view. So as you can see, what I have here is a simple switch with 4 polygons. This is something that I'm sure most of you have seen many times. As you can see, we have a switch with a background and our geometry for our up, our center, and our down positions. So what I'm going to do here, I'm going to go ahead and group all 4 of these objects, the base and the up, center, and down states, into their own mutex group. And I'm going to use this to demonstrate exactly what input device behavior is. Now, for those of you who have used GL Studio for a while, you remember our old input devices. This particular setting for input device behavior is slightly different from the way the input devices used to work. Input device behavior simply states that when it's checked, the first piece of geometry, in this case it's our base, is always going to be visible. So as I said, we have our up geometry, our center geometry, and our down geometry. up, center, and down are going to correspond to array indexes 1, 2, and 3. Inside our mutex group, if I set mutex state equal to 1, we can see that the base, or array index of 0, stays visible. However, also, in addition to array sub 0, array sub 1, or mutex state 1, which is our up geometry, is also visible within the scene. The same thing can be done for mutex state 2, which is our center, and mutex state 3, which is our down. The reason I'm showing this, this can be useful for creating a custom control that might not necessarily be available inside GL Studio as a plugin. Of course, the switch is, but I figured this would be the easiest example to show exactly how a mutex group can be used to simulate this kind of behavior. From there, you can kind of take it and run with it, create your own custom objects or custom controls that can be manipulated and have a solid single base. We are actually finished with our tech demo portion of this. So I hope that this particular presentation on the use of the mutex group is informative to you. Have a wonderful morning, wonderful afternoon, and we'll see you back here at the first of next month.